In this exercise, we are going to learn about the procedures involved in rewinding a three-phase induction motor which has a single-layer concentric type half-coil connection. In concentric winding, the pitch of the coils in the group will be different and will be in concentric form. In whole coil connection winding, the total number of groups shall be equal to the number of phases multiplied by the number of poles, and in the case of half coil connection, the total number of groups shall be equal to the number of phases multiplied by the number pairs of poles. In general, concentric winding is found only in single-phase motors, and occasionally this type of winding is also used in three-phase motors. At the end of this exercise, we will know how to record nameplate details, dismantle the motor, collect winding data, strip the winding and clean the slots, prepare slot liners and insulate the slots, create a former and wind the concentric group of coils, lay the coil groups in the stator slots, connect the coil groups and phase leads, and test run the newly wound motor. The tools required for the purpose are an electrician toolkit, long head nylon hammer, fiber knife, double end spanner set from 5 mm to 22 mm, a scissors, cold chisel, soldering iron, and hacksaw frame with a 30 cm blade. This is a three-phase induction motor having single-layer concentric half-coil winding. Collect the nameplate details and record it on the table. From the details available on the nameplate, calculate the number of poles and write it down. Then, go ahead with the dismantling of the motor. Identify the windings of the motor if it is a single-layer concentric winding. Record the number of slots, coils, and pitch of the coils in the table. Trace the ground and lead connections and make a drawing of the same. Next, record length of the overhang projection and prepare a template to check the overhang after the rewinding is done. Remove the wedges from the slots and strip all the coils out from the stator but for one complete group of coils. We need this group of coils for the sake of measurement and so should not be damaged. Remove this group of coils carefully, check the total coil weight and record it in the table. Using the complete set of coils, measure the size and shape of the coils and record it. Clean the stator slots and insulate them as explained in the previous exercises. The fabrication of the former for this purpose and winding the coils has already been explained. Set the adjustable former to the dimensions of the coil collected in the data table. Wind the designated number of turns in each coil of the group by referring to the table. Leave about 15 centimeters in the starting end of the coil for the purpose of connection. Tie the turns of the coil tightly with a twine thread on either side after winding. Cut the remaining length of the wire, leaving 15 centimeters of extended length. Remove the coil from the former without damage. Verify its size with the stripped out coil. Preferably, insert one set of groups of coils in the assigned slots of the stator and check the overhang, etc. If found correct, wind the required number of coil groups required. Shape the coils by folding the ends in the straight part of the coils. You can use the end connection diagram and developed diagram to insert all of the coils in their respective slots. For a 24 slot, 12 coils, 4 poles single layer concentric winding, this is what we follow. Insert the guide papers in the grooves of slot number 2, which is where the winding insertion begins. Please note that in the concentric type of winding, the insertion of coils should start from the inner coil, which is having the shortest pitch. Insert a separator paper in all the slots over the inserted coils. Then, fold the slot liner and insert wedges in all the slots. Insert a half-moon-shaped insulation paper as face insulator between the coils on either side of the overhang. Connect the group connections of the same phase and solder them according to the end connection and developed diagrams. Then, sleeve the joints. Connect the face leads with the coil groups and insert the sleeve over the joints. Tie the thread to bind the soldered joints along with the overhang. Test the winding as demonstrated to you in the previous exercises and note down the results. Then, finally varnish the windings and test run the motor to ascertain its performance. In this exercise, we learned to rewind a three-phase induction motor of a single layer concentric winding. This type of winding has more advantages than disadvantages. More so, it helps us save on the winding wire, that in turn is a lot of savings on copper. But you require skill to insert the coils in the slots. There are also motors of the same type with double layer winding. In the sense, there will be as many coils as the number of slots.